Today's lesson involves factoring tricky trinomials. And trinomial, of course, means three terms. The tricky part is that there isn't a 1 in front of the x squared term this time, and it can't be factored away from all of the terms. Before we do that, though, we're going to practice factoring the following, and you'll notice there are 4 terms in almost all of these examples except for part C. When we have the 4 terms, we talked about factoring by grouping. So we could pair up terms and look at common factoring within the pairs. So if I look at this first pair, I'm noticing that they have in common a 2 and an x. So we're going to common factor 2x, if I can actually write the letter x here, 2x out of both of those terms, and we're left with x plus 2. So I've divided both of those terms underlined in red by 2x, and I get x plus 2. And then out of the second pair, I have a 3 that's common as well as the y. Common factoring 3 and y out, and I'm left with x plus 2. Well, would you look at that? That's a good thing, because we have this x plus 2 that's common to both terms. So x plus 2 is our common factor, and we're left with a 2x and a plus 3y in our other bracket. All right, and so we've factored part A. Let's try part B. Again, we're going to pair things up. You sometimes want to move things around if it makes more sense. I think I can work with the first pair, and they would have an x in common, and that would leave me with a 2x and a plus 9. And then out of the second pair, I have a y, but they're also both negative, so I'm going to do a negative y as my common factor, which leaves me with a positive 2x and a plus 9, which is what I want, because I want those two brackets to be identical here and here. So 2x plus 9 is the common factor, and it leaves us with an x minus y in our other bracket. Now, if I look at part C does not have the 4 terms, so I can't do the pairing up. There's nothing common to begin with in all 3 pieces, and it's not a simple trinomial. It doesn't have a 1 in front. So this is going to be a little trickier, hence the name tricky trinomial. To get a 2x squared, at the beginnings of my brackets, I know I would have to have a 2x and an x. And then to get a 6, I could have like 1 and 6, or I could have 2 and 3. And then the question is, what would have to go here and here to make that work out? So you can use guess and check with that, but I'm going to show you part D. Part D is very similar to part C, because I have a 2x squared and I have a plus 6. But the center part is plus 4x and plus 3x, which is equivalent to the plus 7x. So this has already been broken down into 4 terms. If I pair the first 2 up, I have a common factor of 2x. So 2x. And then that leaves me with an x plus 2 when I divide those. And the other pair has 3 in common, leaving me with an x plus 2. Oh, that's helpful. That gives me x plus 2 as one of my factors, and my other factor will be the 2x and the plus 3. Okay, so 2x plus 3. So I'm guessing this over here should be 2x plus 3 and x plus 2. But how do we know? All right, so what is the difference between example C and D above? The difference is we broke up the 7x in example C to 2 separate terms in example D. And then we can factor that as the product of 2 binomials. So this breaking up is hard to do. This breaking up of 7x into the 4x and the 3x is a process called decomposition. We're breaking it down. We're decomposing it into 2 pieces. So let's talk about this method of decomposition. To factor a trinomial, ax squared plus bx plus c, we need to break up the bx, the middle term, into 2 pieces. We'll have a polynomial that can be factored by grouping into 2 sets of 2 terms, but we have to make sure we know how that works. How do we choose the 2 pieces? Why did we split 7x into 4x plus 3x? Why didn't we use 1x and 6x or 9x, take away 2x? They all simplify to 7x, but only one actually works. So here's what you need to do, the sum and the product. just like we did the adds and multiplies in simple trinomials, we are going to look at ways to figure out which one works. We chose the two coefficients, or the coefficients of the two terms, to be plus 4 and plus 3 for two reasons. They add to give you the plus 7, but they also multiply to give you plus 12. The plus 12, if I go back up to the top, the plus 12 actually comes from the product of 2 and 6. If I take the A and multiply it by the C, that's where the 12 comes from. So we're not actually finding two numbers that are going to multiply just to the 6. We want to actually find two numbers that add to the middle term, but at the same time multiply to the product of the outsides. So to choose how the middle term splits up, we need to look for two numbers that multiply to whatever you get when you do the A times the C, and at the same time those two numbers have to add to B. Dun dun dun! Alright, so let's look at this in process. So we're going to practice actually factoring these trinomials. First thing I notice is I have three terms, it's a trinomial, and it's not a simple one because I don't have a 1 in front of the x squared. And I can't common factor that 3 away from everything. So I'm going to create a chart here. We want to find two numbers that are going to add to the middle term, so the 8, and multiplies to the two outside terms. So 3 times 4 is 12. Okay, so the 12 comes from the 3 times 4, the A times the C. So factors of 12 would be 1 and 12, 2 and 6, 3 and 4, 4 and 3, which takes us back. Multiplying to a positive, adding to 8, positive 8, 2 and 6 will do that. So we can't just go x plus 2 and x plus 6 because we won't get our 3x squared out of that. What we're going to do instead is break down or decompose the 8x into a 6x plus a 2x. So these two lines I've just written are equivalent to each other because that 8x has just been broken down into a 6x and the 2x. If I pair the first two up, they have 3x in common. So I'm pairing up these first two, dividing both by 3x, and we're left with x plus 2. If I pair up the second two, the second pair, they have a plus 2 in common. I can divide both of those by plus 2, and I'm left with x plus 2 in my second bracket, which is fantastic because these two brackets have to be the same. That is the same as having x plus 2 multiplying, or common factoring the x plus 2 out, and we're left with 3x plus 2. So the x plus 2 multiplies the 3x plus 2. Or you can think of, let me use a different color, this line really is the first line of the expansion of 3x plus 2 times, or multiplying, the x plus 2. Remember that extra line I say you can write in where you take the 3x and multiply it by the bracket? That's really the line up on the second part of my written solution there. So you can think of it either way. All right, try the next one. We're looking for two numbers that are going to add to the b term, adds to -5, and has to multiply to 6 times 1, which is 6. See what you can do with that. Try it. Same with part C. See if you can try part C, and then we'll move forward. And actually try D as well. Try B, C, D, put the video on pause, and then you can take them up. All right, so for part B, I found my factors -2 and -3, worked to multiply to 6 and adds to -5. I broke those down, paired them up for common factors, and was left with a 3x minus 1 multiplying 2x minus 1. My part C here, I was looking for two numbers that add to the b, adds to 2, and multiplies to 3 times 4. 3 times 4 is the 12. And that's where this comes from right here. 1 and 12, 2 and 6, 3 and 4, they both have to have the same sign, and they both have to be positive because we have a positive here. Out of these, I get a 13. Let me not circle that. We get a 13, we get 8, and we get 7. So there's no values here that are going to work. This one does not factor for us. So I'm just going to write does not factor, and that's the end of that. So sometimes questions will come up that won't be able to be factored, and you just write that down, does not factor. Don't leave it blank, otherwise I won't know that you don't know what's going on. I will think you don't know what's going on as opposed to knowing that it doesn't factor. All right, part D, I'm looking for two numbers that add to negative 20 multiplied to 21. Negative 21, and I think if I put a negative with that 21, that will work for us. So we want to decompose that middle term and pair them up for common factors. So 3m squared minus, I'm going to do plus m, and then minus 21m and minus 7. Out of the first pair, m is common. We're left with 3m plus 1. Out of the second pair, minus 7 is common. We're left with 3m plus 1. That's a good thing because the 3m plus 1 is common, and we're multiplying it by m, take away 7. All right, last two examples here. Remember, we always want to look for a common factor first, and if I look at the first, all three terms here, I think they're all even, and the biggest number that can divide all of those would be a 2. So I'm going to take 2 out of that, leaves us with 8x squared plus 13x minus 6. Now we need to find two numbers. So we look at that trinomial, which is a tricky trinomial. Two numbers that add to 13 and multiply to negative 48. So I'm going to come up with those factors. You should too. And then take a look at F2 and see how you can do with that. And with the magic of technology, I have my factors down there. I found that negative 3 and positive 16 will satisfy our requirements here. I'm going to break down that 13x to be, I'm going to put the 16 with the 8x squared. The 13x, I'm going to break that down to be 16x and minus 3x, and then we have our minus 6. The first pair in here, that has an 8x in common. So I'm going to start a square bracket. It doesn't matter that I'm using a square bracket. It's just to distinguish which bracket is which. That's all. When I factor 8x out of those two terms, I get 8x multiplying x plus 2. And then out of the second pair, I could take a minus 3 out of both of those as a common. And it leaves us with an x plus 2 there, which is good. So I've just used the square brackets to distinguish that from the round brackets. But you could just use double round brackets if you would like. All right, x plus 2 is our common. I'm going to pull that out, x plus 2, and it's multiplying 8x and a minus 3. If you don't pull the common factor out first, the numbers that you have to add and multiply to over here will be really big, and it's harder to find what works for those. And plus, it won't be factored fully. You're not going to match Bob because Bob will say you want to factor fully. All right, last example here. Find two numbers that are going to add to negative 31 and multiply to 150. And once again, my factors magically appeared here. I'm wanting to multiply to a positive and add to a negative. So that means the signs have to be the same and they both have to be negatives. So I'm going to make them both negatives, and I'm looking for a pair that are going to add to negative 31. And I think the second last pair adds to negative 31. Now, the difference also with this question is instead of just having my x squared and then my x term and then my constant term, I have the y's added in here. So I am going to break this down. That 31xy is going to break into minus 6xy and a minus 25xy and then plus 10y squared. I'm going to pair them up. The first pair has a 3 and an x in common, leaves us with 5x and a minus 2y. The second pair has minus 5y in common, leaves us with a 5x minus 2y. That's really unfortunate. I wrote that on top of the other thing there. So 5x minus 2y is in both of those brackets. That's common, leaves you with a 3x minus 5y. So key ideas, always common factor first if you can. And then, with whatever's left inside the bracket, if it has a not a 1 in front of the x squared, you want to use that tricky trinomial.